Most people think that good senior engineers are senior because they write better code. This is not actually the case. In this video, I'm going to describe what makes a good senior engineer actually and why it's different to what you think. You can always write better code. You can learn to write better code. You can think in terms of code better. You can construct it better. But you know what I find is that as you grow as an engineer, you do plateau if all it is that you focus on is the code. The real key to being a good senior software engineer is to think in terms of risk. Everything in engineering is about risk. It's trade-offs. What if this? What if that? And as an engineer, you have a unique perspective to really understand the software that you're doing, but also the ability to understand the business or the product or the roadmap. For some people, they can understand the roadmap, but the software is just all jargon to them. They have no idea on how it should be constructed, how complex it is. In fact, I've seen that at multiple companies where the software engineers almost have the rule of the roost because they make up these ideas about how complex it is and so on, and the business just has to trust them. That's a failure on both the business and the engineers. Now, you will do better if you can understand ROI, because then you can provide constructive feedback to the business when they offer suggestions in terms of roadmap, in terms of products they want to launch or develop. There are a couple of risks to think about. There's the risk of being slow. There's the risk of not building the right thing. There's the risk of being too fast. That has happened. There's the risk of operational stability or operational cost. There's all kinds of risks, and a lot of it is dependent on the situation you're in as a business. So in summary, senior engineers prevent costly mistakes. I want to tell you a quick story. When I was a young engineer, around 4 years into my career, I decided to quit my job and become a freelancer. And one of the things I did is I paired up with a friend of mine to build a little prototype product for his boss. Now, they were in an industry where they were doing learning and training for corporate financial services businesses. And the product they were using, at least the software they were using, was pretty crappy. Clearly, they were an incumbent. They'd been there a long time. They were charging these license fees, and they weren't really developing the product. And there were a couple core features that his boss wanted to have. So what we did is we spent maybe 2 weeks and built this really quick prototype, showed that we can do all the cool things that this other software could do, and also the additional things. The additional thing really was this idea of recurring assessments, repeating the same exam, let's say after 1 or 2 years, depending on the compliance rules for the government. And that was really the thing that sold us that business. We got our first customer, and then we scaled that out. Now, my point here is that we could have sat there and built the perfect system, and we wouldn't have got the job. The key was really understanding what was the driver to making the deal and focusing in on that. And that doesn't change. In every business, whether you're a junior engineer, a principal engineer, whether you're a product manager, the key really is to find that thing that's going to make all the difference and go all in on that. Yes, it's risky, but it's also risky doing a whole lot of things that don't matter. So identify that high risk area, whatever that is. Next, use leverage. Many of us like to do things because we like to do things. Software engineers like to write code because they enjoy the process of writing the code and solving these problems and getting really into it. And that's okay. Nothing wrong with that. I love doing that myself. But the key is to spend the majority of your time doing high leverage activities. Now, what do I mean by that? Sometimes you have a choice. I can spend an hour doing this thing and maybe one person will use it every once in a while because it makes their life easier. Or you can spend an hour doing something and 100 people will use this across 100 companies. Can you see the difference? The same hour of work might help 100 or 1,000 people, or it might help one person every now and again. And so in your day-to-day, it's an important question to ask, what is the high leverage activity I can do here? Maybe sometimes you need to take a break and get back to that high leverage activity. You're actually going to be more proficient at your work. You're going to be respected more than spending all your time on low leverage work, only for that to be thrown away or misused. Next, I want to talk about this thinking framework. During my time at AWS, I learned about this idea of one-way door decisions and two-way door decisions. Not much has been said about that. It's been around in a long time. But that really helps frame the thinking in terms of ROI. Is it a two-way door decision? Meaning, is it easy to walk forward and walk back? Is it easy to try something out and quickly undo it? I like to think of it in terms of the cost of undoing is disproportionately small compared to this cost of doing. You can do the thing, and if you want to undo, super easy. One-way door decisions are the reverse of that. The cost of undoing something is disproportionately higher than the cost of doing that. So in effect, you're talking about risk here. What is the risk of failure? And that's a really important way to think. Now, you can apply that across a multitude of different scenarios, but in terms of one-way door and two-way door thinking, it helps me understand the ROI in whatever it is. Lastly, I want to make the point about AI. How does AI fit into all of this? Now, a lot of AI tools are in the markets. It's definitely gaining traction. Anthropic, OpenAI, these are some of the biggest companies, and they weren't even around 10 years ago. And so, how do we do that? I think the key difference here with AI is that all of a sudden code can get thrown away. Now, I'm not meaning to say coding standards should be thrown away, but code used to be this thing that you reuse and you polish and you refine. But yeah, there's a place for that. But you can also now build a tool really quickly to test and prove an idea and throw it away. Effectively, you can take something that might have been a one-way door decision and turn it into a two-way door decision because the cost of implementation is now so much smaller. So use AI to run experiments, use it to prove a concept. Don't use it to run critical path code on really optimizing something. Partly because, I mean, it's fun to learn some of those things, but if you implement that and put it in production, you're not going to be able to really debug and troubleshoot that situation when you're under operational stress. It's really worth understanding how the code works, and you should take time to do that. So in conclusion, a good senior engineer is not just someone that writes better code. It's someone who thinks in terms of ROI. They use a thinking framework like the one-way door, two-way door decision framework to really understand ROI and help drive business outcomes. And they use tools like AI to their advantage to gain high leverage in whatever they do.